My dear students, today we will discuss few more concepts related to computer communication network, that is flow control and error control. Now, what is flow control? What is error control? That is flow control means suppose system here in the network we are having the systems. For example, so many systems are there in the network when they are connected in LAN, local network. Suppose you go to internet at that time, in the internet shop, only 4 5 systems are not there. There may be 10 systems, 20 systems. At that time, suppose you want to transmit the information from system 1 to system 4. At that time, this system may be of using the processor will be of high speed, that is it will transmit and receive the information very fast. But suppose this some data is there, it want to transmit some data from system 1 to system 4. For example, I already told that the packet will be there, frame will be there. It contains the data. It not only contains the data, it contains the source address. It contains the destination address. Means this data should be transmitted from system 1 to system 4. At that time, we don't know what is the processor it is using, how much the fast it is receiving and it is transmitting. But sometimes what happens, the processor this will be of slow. It will receive the data slowly. Suppose it goes on transmitting fastly, but is unable to receive the data simultaneously. Then what happens? Loss of data, loss of information. Therefore, this system not it should transmit the data, and it has to wait for that acknowledgement should come from system 4 to system 1. Afterwards only it has to send the next frames. That is how it will transmit the frames one by one, so that all data will be received successfully by the receiver. That is called a flow control. Control means even though it can fast, it will not fast all the packets, all the data, all the frames fastly to receiver, because we don't know whether this processor receiving speed is fast or slow. We don't know. In previous olden days, at that time the processor microprocessors were there. When we want to execute at that time, 10 years back, 15 years back, when systems were there, at that time we are having only Pentium 2, Pentium 3. At that time, what those processor, the speed, processing speed is little bit slow. Suppose we want to execute some programs. At that time, suppose average of 10 number, separate of even and odd numbers. When we do the programming in microprocessor, microcontroller, at that time, when I execute that one, at that time it will take some 4 5 seconds to execute that program. But nowadays, the microprocessors are very fast. How many of lines of programs will be there? Even the average of 10 numbers or separate even and odd number. Suppose you write program and you click on the execute button, within fraction of second the program will be executed. Why? Why? Because the processing speed of the system, which are there in this system, are very fast. Therefore, day by day, there is also revolution in the field of manufacturing of computers also. For first Pentium, after Pentium 3, Pentium 4, dual core, like this. So many advancement in the field of the processing speed of the system also. There is also different types of processors. Microprocessors are there. No, so many different microcontrollers are invented. Like day by day, there is a revolution in the field of computers also, manufacturing also. Therefore, it may be using some fast processor, it may be using some slow processor. At that time, when it is go on transmitting information, suppose it is unable to receive, then what happens? Data will be lost, packet will be lost. Information, whatever it is having, it has to transmit all the information successfully to system 4. Therefore, what it will do, it will have the flow control. Means it will transmit small data of some packets which are made in the form of frame. When acknowledgement come from this system 4 to system 1, that as I have received one frame was transmitted, afterwards only it will transmit the second frame, and it will wait for some time so that it will send the acknowledgement. After receiving the acknowledgement from the system 4, then only it will transmit one more frame or one more packet to system 4, so that all the data will be transmitted from system 1 to system 4. This is called as flow control. Therefore, already I told that the functions of the data link are, that is framing, flow control, error control, access control are the functions of the data link layer. This is flow control. Error control means if in between some packets are lost in the medium, it is not received all the packets successfully. Some packets are received. At that time, what happens? It will not receive acknowledgement of that frame. At that time, it will come to know that it is not received such and such second packet, third packet, or third frame, fourth frame. It is not received. It will come to know. How it will come to know? Why? Because it will not receive the acknowledgement of those frames. Therefore, what it will do? It will retransmit those frames. Let us suppose one is transmitted successful. Okay, no, because it will receive the acknowledgement. When it will transmit second frame, third frame, suppose it will not receive the acknowledgement, then what it will do? It is having the duplicate copies of those frames, those packets, those data, and it will retransmit those packets to the system 4. And when it second time when it receives the data, packets, frames, it will send the acknowledgement of those frames. Now I have received the frame second, I have received the frame third. When it get the acknowledgement, then only it will transmit the next, the frames, fourth frame, fifth frame. It will transmit the next frames to the system 1 to system 4, so that it will transmit all the data from system 1 to system 4. This is what error control. How it will, the error control means retransmission of the packets which are lost in between the path, in between the medium while transmitting. Therefore, retransmission of the data or packets is called as error control, so that all the packets are successfully received by the receiver. This is flow control. Some protocols are there which are there in the data link layer. Those protocol concept of protocol is important. Protocol means nothing. This data link layer and network layer, transport layer, application layer, session, all are nothing but these are the protocols. Very important. Protocols in computer communication is very protocols mean a set of rules, which governs the communication between the two systems. This is the set of rules which are there in this system 1. It is some voice reference model is there it is there in this system. That is nothing but a software which will take a set of rules which governs the communication between the system, from one system to another. Set of rules which governs the communication between two systems. Here also this system is also having the reference model. There also it is also having that is what the data link layer, network layer, transport layer, session layer, application, like all those layers all will be software only. Only physical layer will be of hardware, like path, some cable, some wire. Physical layer will be of hardware, but upcoming all the layers will be software. That is called as protocols. That is set of rules which governs the communication between the two systems. Now we'll see how these protocols are classified, so that the data link layer will have the flow control and error control. The protocols related to flow control are classified into noiseless channel and noisy channel. Noiseless channels means these are only ideal channels. Ideal channels means it will assume that no other systems are using the path or medium or the path through which the data will be transmitted. Those are called as noiseless channels. Means suppose the system 1, this is transmitting the information from the system 1 to system 4, it will think that 2 and 3 or other systems which are there in the network, they are not using this path, this medium. and this is called as noiseless channel. That is, in that we are having simplest and stop and wait protocol. But it is only it is our assumption. In reality, it is not like that, because system also want to utilize this path. System 2 also want to transmit the path, use this path to transmit the information. System 3, system 4, all system want to utilize this path. Path means some cable, data link layer, some coaxial, it may be some coaxial cable, some wire through which we can transmit the data from one system to other system. Therefore, in reality, the channels, the protocols will be of noisy channels. This channel means the path. This is the path. Channels will be of noisy channels means in real application the protocols will be in the real application. All the systems want to transmit the information to other system. No, not only one system want to transmit the information or use the channel. So many other systems are also there. They want to use the channel. Channel means the path through which the data will be transmitted. Therefore, the real application, the real protocols which are used in real application, those are stop and wait ARQ, go back and ARQ, select to repeat ARQ. These are the protocols which are comes under noise channels. Here, noiseless channel protocols, simplest and stop and wait protocol. First, we'll discuss about the noiseless channels protocols. Afterwards, we'll go for the discussion of noisy channel protocols. These protocols, which are how we can have the flow control in the systems when they are connected in the network. In that, first we will discuss about noiseless channels. In that, we are simplest protocol. Simplest means here this is some system is there. In this system, this is the sender and this is the receiver. At that time, the sender, these are the protocol, that is the frames, the link, the OSI reference model which is there in a sender system. The system is this is system 4 is system. Here receiver is a 4 system, in which we are already, as told that inside we are having the protocols, we are having the layers, network layer will be there, data link layer will be there. Like this, these are the protocols which are there in the system. Then what happens? Suppose sender want to transmit the information. What it will do? Some data it is there. It want to transmit from system 1 to system 4. At that time, what happens? From always while transmission, data transmits from higher layer to lower layer. While receiving, it will transmit from lower layer to higher layers. That is, suppose it is having data, it will send to the network layer, it will come to data link layer. In data link layer, what it will do? It will make frame. The data here, get data, it will take data, and here data link layer will make frame. Frame means what? Frame means it is some making some, it will complete data is divided into some parts and adding the header, trailer, and end of the flag, start of the flag. That is nothing but framing. Dividing the complete memory. In the previous class, I told that dividing the complete memory into the parts is known as framing. Rather, we can call dividing the complete data into small packets, small datas. Suppose 1,000 pages of this book. Instead of the 1,000 pages of this book, will make 100 pages. That is nothing but data. Dividing the complete data and making the frames, packets, small packets, and adding header and trailer. Header is important. I told why header is important, because header contains the source address, the destination address. Means from this system, the data should be transmitted to which system? Because in the network, not only two systems are there, so there are so many systems which are connected in LAN. Now, so far we're discussing about LAN only data link layer. Next, when we discuss about network layer, that comes so many internet. it contains lakhs of systems which are interconnected. But now we are discussing only about data link layer, about the LAN. Suppose when we go to internet shop, how many systems will be there? Maximum 10 systems, 20 systems. We are talking about that. In between the communication, not through internet, we are transmitting the information to other system which are in other state, another, not like that. Within that system, suppose we want to transmit data, how we transmit the data from system 1 to system 4, system 1 to system 10, system 1 to system 20, like within that how we'll transmit the data, the information. That is about data link layer. Will take care of that while systems are connected in LAN. That is called as local area network. That it will get data, make frame. We know that the function of data link layer is what? Framing is function of that data link layer. It will take data, make the frame and send that frame to physical layer for transmission. Therefore data is coming in the form of packets, in the form of frames. Now these packets are called as frames. Data, these frames contains the data and also the source address, the destination. All data will be in packet, is coming to the receiver. When it is come to the receiver, physical layer will receive the frame. In data link layer, what happens? It will receive the frame and it will unframe, or it is here, it is encapsulated with the header and trailer. Here here when it comes here, it will deframe or decapsulate. Means here we have header and trailer to this data. Here in data link layer, it will remove those header and trailer. Only it will transmit the data to the network layer. Here receive frame, get data. Here deliver data is there. Here they are not mentioned data. In the network layer, it will receive the data, not the frame. Here receive. Therefore here you can also, the program is there, the algorithm is there for sender side algorithm, receiver side algorithm. Means in sender side means system 1, what is the algorithm return to transmit the data? That is here, for example, while true, then wait for event. Means some it will be the data link layer wait until any data comes to the data link layer. If event request to send, that is a frame data is coming from network layer to the data link layer, it will take that data, make frame. Here you see, from network layer the data is coming, get data. Network, it is taking data coming from network layer, and in data link layer what it will do, it will get data, make frame. It will make frame. Frame means it will add the header, trailer, it will add start of the flag, start of the frame, end of the frame, that is by adding some flag. It will make the frame, send frame. This is the sender side algorithm for simplest protocol. That is, it will transmit, send frame means it will transmit to the lower part of the, that is, it will transmit to the physical layer. Physical layer is of some of your hardware, and it will transmit this frame to the receiver side. The receiver side will transmit in the form of packets in the frames, and this is how it will transmit the data from source to the destination or to the receiver. In receiver, what it will do, it will wait for event arrival notification. It is when it comes to the data frame, when it comes to the receiver. Here when it comes to the receiver, it will receive frame. Here you see this, receive frame, extract data. Here you see, here it will receive frame. In that frame, from that it will receive data only, because in the frame not only contains data, as I already told that it contains what, it contains the header, trailer, it will add also it is having the flags, start of the delimiter, end of the everything will be there. From that it will extract data only, so that it will be transmitted to the upper layer, deliver to which, where to network, deliver data to network layer. This is the protocol or algorithm which is there in the receiver side. This is some simplest protocol which is there in the noiseless channel. Similarly, we are having the noise. This is one more protocol, stop and wait protocol. Here you see here nowhere it is receiving the acknowledgement. In simplest means it goes on transmitting the frames one by one. Here no acknowledgement is coming from the receiver side to the sender side, so that all frames are received successfully. It will not, here it is simplest protocol. It will not think about whether these packets are transmitted successfully or not. But in stop and wait, what happens? There we are having the error control. Error stop and wait protocol. One more protocol in Nuzless is stop and wait protocol. There what happens? Not only will transmit the data frame, we have to wait. The sender will wait to receive the acknowledgement. When it acknowledgement comes from of this frame, then only it will send the next data. When this acknowledgement will not come, it will not send the next data. It will wait for some time. And if it is not coming, then what happens? It will retransmit that data. Here you see from algorithm how it will, after receiving acknowledgement only, it will retransmit the another packet, and unless and until it is not going to transmit the other frames. Because here how this is how the flow control, how many packets may be there, 10 packets, 100 packets. Whenever this system, for example system 1 is there, when it transmits the data to the receiver, after receiving the acknowledgement only it will send the next data, so that all the data, all the frames are transmitted by, or are transmitted from sender to the receiver successfully. When acknowledgement comes, then only this system, the sender will come to know, it is confirmed that whatever packet, whatever data are transmitted, it is received successfully. If acknowledgement not comes, then how it will come to know whether this data is transmitted, it is received successfully by the receiver? No. Very important. Concept of acknowledgement is very important in computer communication. In previous class also, I told about what is the importance of acknowledgement. Suppose I write some letters or some Xerox copies of my marks card to V2. Along that, I will put in the envelope, and along that I will some small packet of letter I will attach to that. That is called as acknowledgement. There I have mentioned my address. When V2 receives that my Xerox copies of my marks cards, then how I will come to know that all are received successfully by the V2? When that small piece of letter, when I receive back to my address, when I receive that, that is called as acknowledgement. Then only I am become confirmed that whatever data, whatever marks cards, Xerox copies are transmitted to the V2, it is received successfully. Therefore, a concept of acknowledgement is very important. Here also in the system, not only blindly it will not transmit the information. Here also concept of acknowledgement comes. Then only it will think that, okay, yes, whatever data transmitted, received successfully by the receiver. Like these are the protocols. How they will come to know, how they will transmit the data successfully from transmitter to the receiver. Here we see that is how in stop and wait protocol. So what is the algorithm? That is here also same. From network layer get data, in data link layer it will make frame, it will send make frame, and it will send to the physical layer. Physical layer data will be transmitted, and wait for an acknowledgement. Acknowledgement comes and receive that frame. Receive frame means what? That is, this is also a small piece of frame. Acknowledgement is also a small frame. That is a receive frame. Here only unidirectional, we are talking unidirectional, not bidirectional. Both they are not transmitting. Here for simplicity we are discussing only this is transmitting, this is receiving. Okay, in reality it is not like that. This is also transmitting, this is receiving, and also it will transmit and it will receive. I will discuss that one in upcoming protocols, that is in noisy channels. We'll discuss that one. Then what is the sender side algorithm for stop and wait ARQ protocol? It is wait for a can send through, wait for a event, get data. Get data from which? From get data from network layer. Here make frame, that is data link layer, will make frame. Then send frame. Send frame and can send, it will make can send false. Starting it is to now false, because to send the few more frames, it will make the cancelled false. Then wait for event. Wait for event means, wait for event means when acknowledgement, it will wait until it will not transmit the next frame. It wait for it some time. When it receives the acknowledgement, when it receives the acknowledgement, then will it make can send true. Then afterwards only it can send the next packet, next frame. Unless and it will not transmit the next frame. Therefore wait for event, receive frame. Receive, it is the acknowledgement, receive other acknowledgement frame which is coming from receiver to sender, that is receive frame. Can, and afterwards it will make can send is equal to true. Like how it will transmit one by all the packets after receiving the acknowledgement from the receiver. And also what receiver will do, what are the algorithm which is there in the receiver side algorithms for stop and wait protocol. In receiver side, what happens, it will receive the frame which is coming from the senders, from the transmitter, and it will receive, extract the data from the frame. That is from the frame, already I told it contains so many header, trailer, so many flags are there, all it will remove that, and only it will pure data will be transmitted from data link layer to network layer, deliver data to the network layer in the receiver side. Therefore received extra data, deliver data, send frame. What is this send frame? The acknowledgement. Send an acknowledgement, piece of acknowledgement. I have received your frame. It is sending some frame. That is nothing but this acknowledgement. Small piece. It is also called as small information, small frame, telling this system that whatever frame you have transmitted, I have received. This will come back to this. When it receives this acknowledgement, then only this transmitter will send the next frame. Unless and until it will not transmit the next frame. Therefore this is what, how it will have the flow control. Flow control means it may transmit one by one, but it wait. Why wait? Because here in the receiver, the system may be slow, it is not able to receive fastly. Suppose it goes on transmitting, it is unable to receive simultaneously. What happens? Packets are lost between the medium, in the channel, in the path. Therefore to have the flow control, it is stop and wait. After receiving the acknowledgement, then only it will transmit the next frame. Like this is how it is having, it will have the flow control in data link layer. That is how all the data is transmitted successfully from the transmitter to the receiver. Okay, this is about noiseless channel protocols which are there in the in data link layer, in flow, in how we can have the flow control. In next video lecture I will tell about noisy channels in real application, how these what are the protocols will be there, how will they will transmit the information from source to the destination. Okay, okay, thank you.